Hello everyone and welcome back. Today we have 189 rotate array. Here it says we're given an integer array nums and we are to rotate the array to the right by k steps, where k is a non-negative integer. For 3 iterations, we're moving whatever's the last value here. It's as if we're moving this guy, right? It's as if we're moving this to the beginning. Once.
And then twice, twice, and then another time, right?
And that is what's expected. Now, it turns out this actually won't work because we will get time limit exceeded because we'll be constantly updating for each value in k. However, I thought it'd be worthwhile just going over the most intuitive approach, and therein we can actually notice a pattern while doing this first approach. So if we run through, all we're doing is basically whatever we thought to do. If we had no code, if we were to do this just manually as a human, whatever we would be doing, and that's all we would be doing in code for this first iteration, which is, once again, if k is 3, for 3 iterations, for 3 times, so let's do the first time, we'll take the last number, we'll remember it as the previous number, okay? And once we remember that, let's start from the beginning and say, okay, so the current number is whatever the number at this current index is, which happens to be 1 right now, okay? Then we're gonna set the nums of I, so we're remembering the current number. We're remembering it because we're gonna replace it. We remember the current number and then in its place add whatever is remembered, which is the previous number, okay? As in this now becomes this. In the next iteration, oh, and then previous, whatever we remembered over here, we can update here as 1. Okay, this is our new remembered number. Now in this iteration, here, let's follow along. We're at 2, okay? And then the current number is 2. Previously it was 1, so let's update the current value to be what was previous, which is 1. So let's update that to 1, where we're essentially just updating the previous value to our current position. And then we move this guy, where once again, and don't forget to remember this number. So whatever our current number is, we're going to remember it for next time. Our current number is 3. We take in this position whatever is the previous number, which is 2. So let's update that and make sure to remember our current number for the next iteration, 3. Okay, and then we move this along. Current number is a 4. All right, current number is a 4. And then we update our current position to whatever we remembered as a previous number, which is a 3. And then we move along. And I promise this will get faster after the first iteration. Over here, once again, we make sure to remember the previous number, which is a 4 in this case. Our current number is a 5. We set to its current position whatever is the previous number, which is a 4. Okay, and then we move along this guy. Oops, hold on. We got it. We move along this guy over here and we say, okay, once again, we remember the previous number, which was a 5. Here, this is a 6. We're going to put in our current position, whatever is the previous number, which is a 5. Let's update 5. Okay, once we're here, we remember the 6, so we'll update the current number to, well, the current number is 7, and then we'll update it to the previous number, which is a 6, and technically we will remember this over here, to use in a previous iteration, but then our iteration is done. And we will do this basically 2 more times. So that was once. Now k is 2. Then, if you notice here, we shifted by once. Whatever we did manually by hand, that's all we did. We shifted the last value once and then shifted the remaining right bound. So without going through this iteration, if we were to do it again, we would say we would we would remember the 6, move it here, 7 goes here, right? 1 goes here, 2 goes here, this 3 goes here, this 4 goes here, and this 5 goes here. Now there's one more iteration left. Why don't we just complete that? So this is a 5, 5 goes here, this 6 goes here, this 7 goes here, this 1 goes here, 2 goes here, 3 goes here, 4 goes here, and that's essentially what we have. Now, this was done just to say whatever we were thinking of doing manually as a human, it helps because now we can see some pattern, which is, if we notice, do you see that we shifted the last k numbers? K is 3, we shifted the last k, which ended up in the beginning, right? 5, 6, 7. Then all the remaining numbers got shifted to the right. So let's do that again. We have these numbers 1, 2, 3, 4, 5, 6, 7. When we rotated, these 3 get placed in the beginning, right? And then these get placed on the right side. And these maintain order. So if we were to reverse this and 7, 5, 6, 4, 3, 2, 1, what does that do for us? All we did was reverse it, but do you notice now at least whatever the 3 we needed to shift from the back is now in the beginning, right? We achieved it. We achieved the shifting in a way. What's remaining? If we notice, the target is actually 7, 5, 6. Hold on. If we notice, it's actually 7, 6, 5. It should be right. Yeah, 7, 6, 5. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so this was reversed. These 3 are now in the beginning, and whatever was not shifted is now in the back. And then if we rotate these individually, right? If we rotate, if we reverse these, this becomes 5, 6, 7. And what happens here? If we reverse these, it becomes 1, 2, 3, 4. And look at that. That's actually our target. So I don't know if you could come up with this in an interview scenario, but that's basically all it is. If we did this, we do run into time limit exceeded. And then, so the solution was actually to identify this pattern where our goal, our shifted goal, is nothing more than rearranging it so that whatever last k values we want to shift, we just somehow need to move them to the beginning. Ultimately, when we're saying we want to shift, we want to move this to the beginning and shift the rest to the back. And the easiest way to do that is by just reversing the whole thing. Reverse the whole thing, and then instead of the last k, we take the first k and reverse that, and then reverse whatever's after the first k. And that gives us the answer. Okay, so I don't know if it's worthwhile to go over the first example, but I'll just quickly go over in case anyone's interested. So all we did was for each iteration of k, we took some value, which was always our our last number, right? We're remembering the last number and then iterating through the rest. We just took the last number and said, all right, cool. Now for I in the range of however long the nums is, we will remember the current number and then we'll update our current value to whatever previous was now that we remember the current number. And once we do that, we'll update previous to whatever the current number previously originally was, which we remembered it as a variable cur. And we just do that. And it does say do not return anything. Let's give it a run. And so technically it does work, but we run into time limit exceeded. And it makes sense that we do because for each iteration of k, we're essentially shifting just continuously. So that is very inefficient, and this does return as a time limit exceeded. And let's go over the reverse option. And to do that, I'll have a little helper here where we reverse between some range where, as long as the left pointer, wherever the left position is, does not cross the right, we'll update the left and the right to be the opposites of each other. Okay, right? We're just swapping the ends. And then whenever we do that, we need to make sure to move the left forward and the right forward. This is just a standard reverse operation helper that we have. Okay, the main part is we can remember the length of nums and then reverse from initially the whole thing, which is the beginning index to the last index, right? And then after we reversed the whole thing, we first reversed the whole thing, then we reversed it by parts. And the parts were the first k, because the last k was moved or shifted to the beginning. We reversed the first k, which will be from 0 to k, but remember this is the index positions, so k minus 1, then reverse from k until n minus 1. Not the length, we want the index. And again, we're not to return anything, so let's submit. For example, if we do 8 modulo 3, I would be 8 divided by 3. If we do 8 divided by 3, that gives us 2.6666. So 8 divided by 3, excluding the remaining part, would give us a 2. But we want the remainder, because if the k exceeds the size of the array, we just want whatever is the remainder. So if we do 8 modulo 3, that gives us 2, as in we wrap around. In this case, if the length is 3, but their k is 8, we basically wrap around twice to have 6. We have 2 left, then we rotate with 2. Okay, and yep, let's submit. And there you go. Once again, this was 189 rotate array. And we were able to do this in O of 1 space by doing it this way. And reverse, we do anything with reverse. I believe we don't sort, we reverse, so that's kind of a linear operation. We do it a few times. I'll reduce this down to 11. I believe this is the right time. Please comment below if it's not. Thanks so much. Happy coding. See you next time.